Hi and welcome to Gaffy's Grinds. In this video, we're going to do the ordinary level titration question from the 2019 paper. So grab your calculator, grab your periodic table, and grab a copy of the exam papers and a piece of paper to write on. Okay, so we're going to begin. We're going to jump straight in. We're going to try and fly through this. Like I say, I reckon a higher level student should do this in 10 minutes, 10 to 15. Ordinary level student may take the full 20 minutes. All right, so I'm going to ask you to pause the video. I'm going to ask you to read the text at the top of question 2 here. So just this bit up as far as here. Highlight anything you think might be important. All right, we may need to come back to that stuff later. All right, but for now, we're going to jump into the questions. So question 2A. All right, so it says, explain why would a beaker not be a suitable alternative to a conical flask? So this here is a setup in a titration. You should be familiar with it. You have this piece of equipment up here that holds, in this case, it's holding HCl, and then you have sodium carbonate in this conical flask below. And the question is, why would you not use a beaker? So pausing the video, I'm writing down why is a conical flask better than a beaker here. All right, so your possible answers here, I'm looking at the marking scheme. As you can see, this is why we would not use a beaker. And look at the possible answers. All of these are acceptable. I think the biggest things that you may have gone here is that it would be more easy to spill or splash, or contents lost by splashing. It's easy to get those marks. Some people may say a beaker is harder to swirl, and we know we need constant swirling while we are doing titration. So have a look at them possible answers and check, did I say something that would get those marks? All right, so hopefully we did, and you agree that your answer is as good as them, and we will give yourselves a mark out of 5 there. So 5 marks for it correct. Good stuff. Let's move on to the next one. We're really moving here, really motoring. First of all, then it says, what is the correct procedure for rinsing these 2 pieces of equipment? So first of all, this is B part 1. B part 1. Explain how you rinse the pipette. And then B part 2, explain how you rinse the conical flask. Okay, be as detailed as you can. What is involved in the rinsing? Pause the video and write down your answers to that now. Okay, so hopefully you have an answer for both of those. Pretty straightforward, and we're moving over here. Okay, so B part 1, this is for the pipette. First of all, and look here, see this double line means you have to have the thing before and the thing after. If it's a single line, then you can have either the one before or the one after. You can have either of those. But if it's a double line, then you have to have, that means that this here is the first answer that you have to have. So you have to have this line, and then you have to have one of the next 2, okay? So interesting here, you had to say rinse with deionized water or distilled water or pure water, any of those. And then you had to say rinse with either sodium carbonate or rinse with the solution the pipette's going to hold. That's 2 by 3 marks there. You guys very familiar with those procedures. I would imagine that you got those right. Give yourself 6 if you got both of them. Rinse with deionized, rinse with the solution it's going to contain. Next thing is for the conical, it's rinse with deionized water only. Okay, and look here, it says if you use a second rinse, and if you said rinse with the solution it's going to contain, you lost the 3 marks. So it's very important. The conical flask is only deionized water. If we rinse with the solution it's going to contain, we put extra moles in there because there'll be a few drops left over. And when you put in your 25 mils, you'll have 25 and a little bit that you use for rinsing. And then we don't know the exact volume. Okay. All right, so well done. If you got those marks, giving yourselves a mark out of 9 then. Let's see what part C is. It says the clamp shown in the diagram is designed to keep the burette vertical. State another precaution that a student should take to ensure accuracy when reading the volume of HCl added from the burette during a titration. All right, there's quite a lot of text there. If you need to pause the video and read that again slowly yourself, do it now. Okay, and now you should be ready to answer. How do we make sure that when we read this burette, that we're being accurate? So accuracy when reading the burette. So as well as keeping it vertically clamped, that just means up straight and not bent over or not leaning or anything like that, up straight. What else can we do for accuracy with the burette? Pause the video and write an answer down now. Okay, let's check the possible solutions, the possible answers here. Okay, so read at eye level, that would have got you the marks. If we place the white colored tile behind, so when you're reading the burette, If the burette is here, you place a piece of paper behind so you have a white background to read the numbers better. That's not really one I would think of. Reading at eye level, I would. Read at the bottom of the meniscus will get you the marks. So eye level or bottom of the meniscus, both of them get you the marks. And make sure the space below the tap. Make sure you fill the jet before you start the titration. Any of those, nice 6 marks. Really easy. Give yourself 6 marks if you got them right. Good. Let's move on to part D. Okay, so part D says give one property of the chemical sodium carbonate, Na2CO3, that makes it suitable for use as a primary standard. So what are the things we require for a primary standard? Okay, to be called a primary standard, give me one feature or one property that we know about sodium carbonate. It has to be, what are the things it needs to be? Pause the video and write them out now. So that's D part 1. We'll check the answers in a second for sodium carbonate as a primary standard. D part 2, it says the 0.05 molar solution of sodium carbonate is a standard solution. Explain this term. What does standard solution mean? So we've made up the solution and it's now a standard solution. What exactly does this mean? What is the definition of a standard solution? Pause the video, write down your answer. All right, let's check the part D. All right, any of these things will get you the marks for what does a primary standard mean. It's pure, it's solid, it's soluble, and it's stable. They're the ones I always ask my students to remember. Primary standards are pure, stable, and soluble. PSS, pure, stable, and soluble. If they're not soluble, you can't make a solution. If they're not stable, then by the time you weigh them out and put them in the solution, they've already broke down and you don't have that amount of grams anymore. And if they're not pure, well then you don't have 2.7 grams of that substance, you have 2.6 something, and then you have a little bit of something else. So it's not exactly, it's not exactly known amount of it. Okay, there's other things here as well. You may have said some of them. Pause the video and read through them. Any of those will get you the marks too. And then the next thing is, what is a standard solution? It's a solution who we know the concentration of. So that's what a standard solution is. A solution whose concentration we know accurately. All right, let's look at the next question now. E, indicator. Always stuff about the indicator. This is the titration. These are the chemicals that we're mixing, HCl and sodium carbonate. So it's the exact same as the other ordinary level ones. What are the indicators? It's only one indicator and one color change you really need to remember for ordinary level. Writing down E. First of all, write down indicator. And then you're going to write down that. So that's the name. And then you're writing down the color change. Pause the video and write those two things down now. Again, a reminder, don't wait for me to do it. Don't wait for me to show you. You have to be trying to do this. All right, let's check the answers to those. The indicators, it's methyl orange is the indicator because it's a strong acid HCl and a weak base sodium carbonate. Strong acid, weak base, methyl orange. Remember this, sub mo. Strong acid, weak base, methyl orange. Okay, color change is yellow in a base to pink in an acid. So yellow in the conical flask with sodium carbonate. And when it turns acidic at the end, because you're adding HCl, turns to red. Easy. All right, all the marks hopefully we've got so far. And we're now on to the calculation. Okay, so it says the equation for the calculation is shown here. And then I'm going to ask you to pause the video and read this piece of text right here. Pause the video, do that now. Okay, so you should have read through this. You will notice that this wording is a lot easier than in the higher level. And as well, like they've given you the information a few times. They give you a lot of information up here, but then they give it to you again down here where you actually need it. On the higher level paper, they don't do this. You have to go up and down through the pieces of text looking for the information. Process is always the same. Write down the balanced equation. Do that now. Pause the video, do that now. Okay, and you should have got 2 HCl plus Na2CO3. The rest of the equation is pretty useless here. They're the products, but we're really interested in how do the two reactants react. Okay, I always tell my students to use 2 arrows, one here and one here, like this. And you guys should know how to do this now. So pause the video and write down the things you need to know on those arrows. Okay, on those arrows, just a reminder, you should have the concentration in moles per liter or molarity, and you should have the volume used in each titration in liters. Okay, so pause the video if you didn't know that and do this now. All right, so for the HCl, what does it tell us? The student carried out a number of titrations and note that on average, 22.6 centimeters cubed of the hydrochloric acid solution were used. So that was the 22.6 centimeters cubed was the volume of hydrochloric acid used in a titration. We need that in liters, please. So if you didn't do that, pause the video, do it now, convert to liters. Okay, that is 0.0226 liters. Okay, this is what we're trying to find. Notice here it says calculate concentration of HCl. So this is question mark molarity. That means we should definitely know the other two. So if that's not what you did, pause the video now. You have another chance to fill out these two arrows. Okay, so hopefully you can see that this is 0.05 molar of sodium carbonate, 0.05 m, and we use 25 cm cubed on average, which is 0.025 liters. Okay, if those of you who are getting confident at this should be able to pause the video, plan out the rest of the calculation and do the calculation. Pause the video, do that now. Okay, if you did that, then this is the answer you should get, 0.11 moles per liter. Moles per liter of HCl. Okay, if you got that, well done. If you did not get that, pause the video and try and get that now. Find out what you did wrong. You didn't get this answer at the end. There's something that you did wrong. Pause the video and find the answer. Okay, so hopefully you got there now. If you didn't get there now, you must be getting frustrated. You may need to go back to basics again, back to the start, and figure out these conversions. And if not, you can watch me do it now. But I advise you, please do not just watch this video through and don't try and do them yourself. Okay. All right. So start with what you know. We know the sodium carbonate. This is our known, and this is our unknown. So we always start with our known. And at this stage, you should also recognize that this is 2-to-1 molar ratio. Okay, so I'm writing down, starting with what I know. I know I have a 0.05 moles of Na2CO3 per liter, so per over liters solution, so per 1 liter. And I want to cancel that and end up with moles. So the plan for this should have been to go from moles per liter of Na2CO3 and end up with just moles of Na2CO3 per titration. I want to find the moles used per titration to get rid of the liters. Then I want to find how many moles of HCl that reacted with. And then I wanted to find out what was the molarity of that solution, so moles per liter of the HCl. That's the plan. Okay, so this is what I'm doing here. If you now know how to do it, pause the video and try and finish it. All right, so I've got 0.5 moles of Na2CO3 per liter. I want my liters to cancel, which means I need to multiply by a number of liters here. So some number of liters. What is that number of liters? The number of liters I used in each titration. So 0.025. Getting out my calculator, I'm going to do this now. So I've got 0.05 times by 0.025, and that gives me 1.25 by 10 to the minus 3. 1.25 times 10 to the minus 3, and that's moles of Na2CO3. How do I know it's moles of Na2CO3? Well, I see that this is liters here over, which is the same here. So I could just extend that line. It's liters over liters, which cancel. Okay, so I'm going to get rid of that there. And this is how this has got me to here. I now want to compare moles of Na2CO3. How many moles of HCl did that react with? So I'm going to go to the next line to do that. So I'm rewriting this out down here. 1.25 times 10 to the minus 3. And that's moles of Na2CO3. And of course, I don't want that in my answer. I want those to cancel. So I need a conversion factor that has moles of Na2CO3 on the base here. And it's got moles then, because I'm trying to go to moles of HCl. So moles of HCl on the top. So I know that moles of HCl over moles of HCl cancels. And the next thing I need to know is what's the relationship between moles of HCl and moles of Na2CO3. So looking through all the information I have for that, well, here I see that there are 2 moles of HCl for 1 mole of sodium carbonate. So that means this is 2 HCl, 1 Na2CO3. And that's given me 2.5 times 10 to the minus 3. And of course, the only unit that's left here is this one, moles of HCl. Moles of HCl. So now I have got as far as here. So I'm going to do this now as number 3. So this is step 3. I've got moles of HCl. I've got this bit. That's what I found here. But I want it to be moles per liter. So how do I do that? Well, I put it over the number of liters that this was in. So this was 2.5 moles, 2.5 by 10 to the minus 3 moles of HCl, but this was in a certain volume. This was the volume, 0.0226 liters. So I'm going to go ahead and put that there, divide that by 0.0226 liters. And the answer I'm getting is 0.11. So equals to 0.11 molar HCl. Okay, so well done. If you got that by yourself, if you got that with some help, it's better than nothing. But you should now be getting confident enough to be getting way ahead of me. Well done. Stop your timer. How long did that take? Hopefully it wasn't any more than 10, 12 minutes. I know it can be a little bit longer than that when we're talking our way through it. I'm trying to keep them as short as I can. I hope you found this helpful. It was definitely shorter than the previous ones, and I'm going to be going through them quickly like this now. All right, so I'll see you in the next one.